Okay, these are already in the form of y equals mx plus b. The m is the slope, and that's the number in front of the x. So this slope is 2/3. This slope is -3/2. These are opposites, meaning the different signs, and the reciprocals. If you flip them upside down, they're the same. So opposite reciprocal slopes are perpendicular. These are also in the form y equals mx plus b already. So this slope is the number in front of the x, which is 3. This slope is the number in front of the x, which is also 3. These have the same slope, so they're parallel. These are also y equal, so they're in the slope-intercept form. So the slope of this one is the 3/5. The slope of this is -3/5. Now these are opposites, different signs, but they're not reciprocals. So they need to be both opposite and reciprocals to be perpendicular. So these are neither. Okay, this is in the form y equals mx plus b. So this is, the slope of this is 2. The slope of this, we don't know yet, so I'm going to move this x over, and it's going to flip sign, so I have -3y equals -6x. I can drop this 9 because it doesn't contribute to the slope. If all I'm after is the slope, this plus 9 doesn't matter. And then I can divide by -3. Don't worry about this. If you want, you divide by -3 there. And you'll get y is equal to positive 2x. This is -3, but again, this part doesn't matter. The slope of this is positive 2. These have the same slope, so these are parallel. Before we find the slope of this, let's solve for y. So I'm going to move my x over to the right, and that's going to become negative. So I have -8y is equal to -6x. I don't need this. It doesn't matter what that is. If you leave it, that's fine. But anyway, I'm going to divide by -8, and I'm going to get y is equal to positive 3/4 x, and this is going to be -2. Again, this part doesn't matter. Our slope is the number in front of the x, which is 3/4. For this, I'll move this over, and I have 3y is equal to -4x. Again, this plus 3 part doesn't matter because we're not after the y-intercept. Now we'll divide by 3. And again, this part doesn't matter. But we'll have y is equal to -4/3 x. This is plus 1, but again, you can just drop this. You don't need to worry about that. The slope of this is right here, -4/3. These are opposites, different signs, and they're reciprocals, so these are perpendicular lines. We're going to put this into slope-intercept form by dividing by 5. And again, don't worry about this right here. We can just drop that. So we're going to get y is equal to 2/5 x. This is -1, but again, this doesn't matter. So our slope is 2/5. It's the number in front of this. When we move this over, we're going to get 5y equal to -2x plus 15. And then we'll divide by 5. So we'll get y is equal to -2/5 x. And again, this is plus 3, but you could just not even write that. It doesn't matter. The slope here is -2/5. These are opposites, but they're not reciprocals, so these are neither. Okay, y equals 4. If you think about what y equals 4 looks like, that's, down -4. That's a line down here. Okay? And then x equals 4, you go over here, and that's a vertical line this way. So the slope of this is a slope of 0. The slope of this is undefined. And these are obviously perpendicular. Okay, if we think about a graph, x equals -2 is a line here. X equals -1/2 is a line here. These are both vertical lines, so they both have undefined slopes. And they're parallel. For this problem, this is already in slope-intercept form. So the slope is 2, and the slope is 1/2. These are not opposites. They are reciprocals, but they're not opposite reciprocals, so it's neither. the slope is y2 minus y1 over x2 minus x1. y2 is the y value of the second point minus y1, which is the y value of the first point, over, this is the slope of 1, over x2, which is the x value of the second point, minus x1, which is the x value of the first point. So this is 2 over negative 4, which is negative 1/2. The slope of the second line is y2, which is the y value of the second point, minus y1, which is negative 2, over x2, which is the x value of the second point, negative 1, minus x1, which is the x value of the first point, which is negative 5. 6 plus 2 is 8. Negative 1 plus 5 is 4. So this is positive 2. These are opposite reciprocals, so these are perpendicular. Okay, remember that the slope is y2 minus y1 over x2 minus x1. In this problem, our y values are the same. That means we're subtracting the same value up top. That gives us a 0 on the top of the fraction, which is 0. And that's the same over here. The y values are the same, so you're going to have 0 on the top of the fraction, which is 0. Now these are both horizontal lines. Slopes of 0 are horizontal, so these are parallel. On this problem, notice that the x values are the same, and the x values are on the bottom. When you subtract the same value, you get 0. Anything over 0 is undefined. On this problem, the y values are the same, and that's on top, so you have 0 over something, which is 0. So this is a vertical line. This is a horizontal line. These are perpendicular. Okay, I'm going to use the intercept method because x and y both go into 6. If I cross this out, 2x is 6, so x is 3. If I cross this out, 3y is 6, so y is 2. And then I'm going to graph this using a straight edge. There's an equal sign here, so I'm going to draw a solid line. Now, if you consider the x values, x goes left, right. So this is greater. This is a positive x, so we go to the right side of this. So when I graph this, I'm going to shade this side of the right side of it. If I had considered the y's go up, down. This is a positive y and it's greater, so we'd shade the upper side. They'll always be in agreement, so you only have to consider one variable. Because 5 and 2 both go into 10, I'm going to use the intercept method. If I cross the y out, x is 2. So I put a dot on 2 on the, oops, let me do that with a smaller dot. Okay. And then if I cross out x, negative 2y is 10, so y is negative 5. I'll put a dot on negative 5. This is a dashed line because there's no equals here. Oops. Make sure you put arrows on either side of the line. Now, if we consider the x goes left, right. This is positive and this is less than, so we're going this side. So I'm going to shade on this side of the line. Now, if you had considered the y's instead of the x's, remember that y's go up, down. Normally you think you'd go down because it's less than, but this is a negative y, so you do the opposite of that and go upward, same side of the line. So either consider the x or the y, it doesn't matter. Because both 4 and 3 go into 12, I'm going to use the intercept method. If I cross this out, 4x is 12, so x is 3. Oops. Let me draw a better dot. X is 3. If I cross out the x, negative 3y is 12, so y is negative 4. So on the y-axis at negative 4, I make a dot. Okay, because there's no equal sign, we're going to draw a dashed line. So get a ruler, a dashed line, put arrows on either side of it. Now, for the shading, if you look at the x's, this is positive. X's go left, right, so you follow this. We go to the left. So I would shade on this side, the left side of it. Now, had you considered the y's go up, down. This is a negative, so you have to do the opposite of this. So instead of going down, because this is negative, you go up, which is the same side of the line. Okay, this is not a good candidate for the intercept method because 5 doesn't go into 8. So I'm going to put this in the slope-intercept form. So we'll solve for y by moving the, I'll move the 4x over. I mean the 5x over. And that's going to become negative. So we have 4y is equal to negative 5x, not equal, less than or equal to negative 5x plus 8. And then I'm going to divide everything by 4. And we're going to get y is less than or equal to negative 5/4 x plus 2. So this is my y-intercept. On the y-axis, I'll put a dot at 2. You can put this negative in the numerator or in the denominator, just not both. If I put it in the numerator, that means I'm going down 5. But then this is positive, so I'm going right 4. So that's the point right there. Had I put this in the denominator, I would have gone, this would be positive, I'd go up 5, but then this would be negative, so I'd go left 4. And either way, it's going to be on the same line. So now I'm going to grab a ruler. Because there's an equal sign here, I'm going to draw a solid line. Now, I prefer to shade from the original equation in case I made a mistake when I solved this. So on the original equation, the x is a positive x, and this is on the left-hand side. X's go left, right, so I'm going to shade to the left here. So I'll shade on the left-hand side of this. Now, if I were shading using the y's go up, down. This is a positive y, so I do the less than, the lower side of this, which is this side. So either think of the x or the y, they'll always be in agreement. For this problem, this is already in slope-intercept form. So here's my y-intercept. On the y-axis at 4, I'm going to make a dot. Okay? And then my slope is negative 3. As a fraction, it's negative 3 over 1. So I'm going to go down 3 and run 1. There's no equal sign here, so I'm going to draw a dashed line. So I grab my ruler and draw a dashed line. Now, the only variable on the left is the y, so we have to think of up, down. This is a positive y and it's greater than, so I'm shading the upper side. So I'm shading this side of the line. That's that. This is already in slope-intercept form. So here's my y-intercept. On the y-axis at positive 1, I'll put a dot. My slope is a negative 3 over positive 5. So I go down 3, but I run right 5. There's an equal sign here, so I'm going to draw a solid line when I graph this. Put arrows on either side. Now, the only variable on the left of this is the y, so we got to think up, down. This is a positive y, and it's less than, so I'm shading on the lower side of this. So I'm shading down here. Okay, this is not a good candidate for the intercept method because 4 doesn't go into 10. So I'm going to put this into slope-intercept form by moving the 4 over. So I have negative 5y is greater than, this becomes negative 4x plus 10. And then I'm going to solve by dividing by negative 5. Because I'm dividing by a negative number, this inequality is going to flip directions. This becomes a positive 4/5 and a negative 2. So on the y-axis at negative 2, I'm going to put a dot. This is a positive 4 over positive 5. So I'm going to rise 4 and I'm going to run 5. There's no equal sign here, so I'm going to draw a dashed line. Now when I decide which side to shade, instead of looking at this, because it's easy to make a mistake and forget to flip the inequality, and if you forgot to flip the inequality, you accidentally shade on the upper side. So the original problem doesn't have a mistake. So I'm going to look at the original problem to shade. The x's go left, right. If this is positive, follow this. So this is going to be on the right side of this. So when I shade, I'll shade to the right side of this. If you instead had thought of the y's instead of the x's, y's go up, down. But this is a negative y, so you got to do the opposite of this. So instead of going up, we go down, which is still the same side. Now I think it's probably better to shade from this rather than from this, because if you accidentally made a mistake and forgot to flip the inequality, then you would have accidentally shaded on the upper side. This problem, again, is not good for the intercept method because 4 doesn't go into 15. So I'm going to put this into slope-intercept form by moving the 4x over. And I'm going to use a different... Okay, I'll move the 4x to the other side, and that's going to become negative when it's on the other side. So I have 5y. This is not flipping because we're just moving a term. What am I doing? Is less than negative 4x plus 15. And then I'll divide everything by 5. And I'll get y. Now we're dividing by a positive number, so this is not flipping. So y is less than negative 4/5 x plus 3. So on the y-axis at positive 3, we'll put a dot. This is a negative 4 over positive 5. So I'm going to go down 4, but I'm going to run 5, and I'll put a dot there. There's no equal sign, so I'm going to graph a dashed line. By the way, I put the negative on my slope in the numerator. If you instead put it in the denominator, this would be a positive 4 over negative 5. So from this, a positive 4 is 1, 2, 3, 4. And then left 1, 2, 3, 4, 5. It still would have been on this line. So it doesn't matter where you put the negative. Just don't put it in both the numerator and the denominator. Okay, I always like to look at the original when I decide which way to shade. If you look at x's and x's go left, right, if this is positive, you follow that arrow. So I'm going to go to the left-hand side of it. If you instead had considered the y's go up, down. This is a positive y, so follow this arrow downside, which is the same. Because 2 and 1 go into 4, I'm going to use the intercept method for this. This tells me x is 2. And this tells me y is 4. And that we have a solid line. So when I graph this, it's going to look like this. Now, because this is an and, I'm only going to be shading the intersection, so I'm not ready to shade until I graph this. But if I want, I can remind myself that the x's go left, right, and this is a positive x on the left-hand side, so I'm going to be shading this way. So I'm going to put a tiny little arrow reminding myself I'm going to shade on that side of the line. For the y's, y is greater than or equal to negative 1, so on the y-axis at negative 1, I'll put a dot. And this is a horizontal line. And it's solid because of the equal sign. And I'm going to be shading on the upper side of this line. So the intersecting portion where you're shading on this side of this line and this side of this line is shading this area right here. So I'm going to be shading right in there. This one's an or, so you're going to shade everything, not just the intersection. So x is greater than negative 3 is a dashed line because there's no equal sign. At negative 3, it's vertical. y is less than 2. At 2 on the y-axis, we'll draw a horizontal line. And again, it's dashed because there's no equal. And when I go to shade, I'm shading everything to the greater side of the x line. So I'm shading everything on this side of this line. And I'm shading everything to the lower side, the underside of this line. So everything down here as well. So the only portion that doesn't get shaded in this graph is this top little portion up here. This is slope-intercept form. My y-intercept is 4, so up on the y-axis at 4, I'll put a dot. And my slope is 1, which is 1 over 1. So I'll rise 1 and run 1, and I'll put a dot. This is going to be a dashed line because there's no equal sign. And arrows on either side. Now, this is an and, so I'm only going to shade the intersection, so I can't shade yet. I got to wait till I plot this line. But if I want to remind myself, I'm going to shade y's go up, down, and this is less than. So I'm going to shade on the lower side of this line, so I can draw a tiny arrow to remind myself. Now, on this line, it's slope-intercept form already. So on the y-axis at +1, I'll draw a dot. This is a negative. I'll put the negative in the numerator, or you can put it in the denominator. I'll just put it in the numerator. So this is a -3, but +4. And I'll put a dot there. Okay? Now, there's no equal sign here, so I'm going to draw a dashed line. And I'll put arrows on either side. Now, when I go to shade, this is going to, y's go up and down. This is the greater side of this line, so I'm going to shade up on this side of this line. So if I'm shading on this side of this line, but this side of this line, only this portion in here gets shaded, and so I'll shade right in here. Both 2 and 3 go into 6, so I'm going to use the intercept method. This tells me x is 3, so on the x-axis at +3, I put a dot. -3y is 6 tells me y is -2, so on the -2 on the y-axis, I put a dot. There's an equal sign here, so I'm going to do a solid line. And I'm going to be shading. If you look at the x's, x go left, right, this is positive, so it's greater, so I'm going to shade on the right side of this line. So I can shade it now because this is an or, so I'm shading everything anyway. So you can shade the right side of this line. Oops, what am I doing? Okay, now for the next line, x is less than 2 is a vertical line on 2, and it's dashed because there's no equal sign. And less than is the left side of it. So now I got to shade everything on the left side of this line. I already shaded below that line, so I don't need to shade more over there. So everything gets shaded except for this portion right here. Here we have an absolute value that's less than a positive number. So I'm going to have, because it's less than, one interval. Because it's one interval, I'm going to use the sandwich method. I'll take this out of the absolute value, and I'm going to sandwich this in between using these same symbols on either side, the negative and positive version of that. And I'm going to solve for the middle portion. So I'm going to bring the x out to each side by adding 2 to each section. And I'm going to get 0. So these are vertical lines. One at x is equal to 0, and it's solid. So x is 0 is this line right here. Oops. What did I just do? and 1 and x equals 4, which is a vertical line right here. And I'm going to shade everything in between those two values, so everything in here. Here we have an absolute value that's greater than a positive number. So now I know I'm going to have 2 intervals when I'm done. So I'm going to set this up twice. I'll take this out of the absolute value, and I'll leave this and this alone. And I'll go comma, take it out of the absolute value, and I'll flip both of those things. When I subtract 1 from each side, I have y is greater than 3 minus 1 is 2. When I bring this over here, I have y is less than negative 3 minus 1 is negative 4. So this is a horizontal line that's dashed. There's no equals at y is 2. So I'll grab my ruler and I'll put a dashed line here. And this is a horizontal line at negative 4. So I'll put a dashed line here. Now, greater goes up, so it's on this side of the line. And less than goes down, so it's on this side of this line. The important thing to remember is I knew I was going to have 2 shaded regions when I was done because we had an absolute value greater than a positive number. On this problem, I knew I was going to have 1 shaded region and therefore use the sandwich method when I was done because we had an absolute value less than a positive number. And that's it.